thank you very much, and I'm going to turn this over to our next speaker, and then both of us will be around to take questions after.
Thank you very much, Andrew. Now our next speaker, his name is Ugo Nanni, and he works at the University of Oslo in glacier instability, and he will tell us. Thank you. He's going to tell us about what the glaciers have to say beneath the hundreds of meters of the surface. He works in the Alps and also in glaciers in the Arctic. So please go.
Great. Thank you. Can you hear me well? Ah, great. So today I wanted to present you both some results that we obtained on a glacier in the Arctic, but also a new perspective on listening to the glacier and listening to some voices that we are not that common to listen to, and that's why I entitled my presentation The Whisper of the Glacier. So you will see through this presentation there will be quite a few QR codes that you can flash and access different information, which could be sound, but which could be also some article explaining what is the sound of the glacier. So as Sebastian said, I'm working in Oslo in Norway, and I'm mostly focusing on the Arctic glacier, and everything that I'm going to present today has been in collaboration with different institutions in Norway, which seismological institution, but also glaciological institution. So, I just wanted to start with this image of a flowing glacier. So we talk a lot about glaciers, and sometimes I have the feeling that we think it's a static object that can melt or just be present. But actually a glacier is a moving object. And when you look over here, it's 20 years in the Karakoram, which is island in Asia. So it's obtained from satellite imagery. You can see that the ice is flowing. And when you see that this time scale, the ice is actually flowing like a river, or moving like almost an animal or a human entity. And that's what I wanted to highlight here. It's depending on the perspective you take, that the object we study can have a different meaning. And we can go back like to the simple explanation why the glacier is moving and why the glacier is melting. So one part of the glacier, often the upper part, is where the snow accumulates from year to year. Then as the glacier flows down, as it deforms under its own weight, it reaches altitude or latitude, where the sun is so strong that it will melt the ice, and therefore the glaciers start to melt. And when the melt is higher than the accumulation, so where the snow goes, then the glacier will shrink, and this is what we'll be explaining in this Cryosphere Pavilion about the melting glacier, depending on the different temperature. But the mechanism of a glacier, when you see it like this, is quite simple. And you can see that we have different colors and different arrows. Because as the glacier melts, we have the water that can penetrate at the base of the glacier. And okay, I won't talk too much about the physics, but this is quite important because as the water goes at the base of the glacier, it will lubricate the base of the glacier and might cause unexpected events or maybe collapse of the glacier. So what's happening in response to surface melt is quite important to determine how a glacier behaves. Because as the water reaches the bed of the glacier, it could reach the bed and act in different manners. If the bed of the glacier is well organized, then you will have a drainage system as the one you can have on the side of the road. Then the more water won't have any effect. But for some glacier, if you put a little bit of water, then it will be like a slippery road in winter or during rain events. So just to highlight that there is not a strong relationship and a unique relationship. And these non-unique relationships may lead to some unexpected events that are called glacier surge. So again, I take you in the Karakoram, in the same area as before, with the same timeline. And before you could see that the glacier was gently flowing, just like a normal river. But in this figure, you can see that some of the glacier just fall down towards the glacier, like almost if they were collapsing as an instantaneous collapse. And of course, the other end member would be what happened last summer in the European Alps in Italy, where glaciers have been detaching and then falling on a few hikers and mountaineer people. So just to highlight that glacier can be flowing in different manners, and the way the water will influence the glacier really influence the way the water will behave. And what we are doing with my team is to try to understand what can trigger such events, which is both interesting from a scientific point of view, but of course it's interesting from an early warning or maybe a risk analysis. This is a bit just a recall of the headlines that happens in the Alps. And of course it also recently happened in Pakistan in last May, where a glacier triggered just a big flood and a lot of people were impacted by that. And this is what we are trying to understand, what could be the impact and how can we better understand what's happening. And to do so, I want to introduce you to the method I'm using, which is seismology. I guess most of you know seismology for earthquake. So earthquake is, two plates that moves and create a vibration, and then you can put a seismic station and look at ground shaking. But the same thing happens in the ice. As I showed you before, the ice is moving, and of course you can have different processes that will create vibrations that could be recorded by seismometers. And this is what I do. And this is why I was telling that I'm listening to the glacier. Because when you look at the wave, the ground shaking, it's just a sound, and it travels within the glacier in a similar manner. So we installed this instrument, and we went up north. Told you I'm from Norway, so we went up north to Svalbard, where a lot of glaciers are surging, and we are trying to understand what's happening. So, of course, it's not a place that impacts directly a lot of people, but a mechanism, because it's near Norway, but also because there are a lot of glaciers are very sensitive to this surge or collapse events. So it's a really good place to investigate such processes. And we targeted a glacier, so this is my only physical figure of the presentation. The color bars show the time. So green is 20 years ago, and pink is now. And, okay. Well, it's right in front, this is the front of the glacier, and then, so the glacier is flowing towards me. It's a 20-kilometer long glacier, and we have observed that over the past 20 years, the glacier velocity has been increasing almost by tenfold. Like 20 years ago in the 90s, the glacier was really quiet, and now the glacier starts to accelerate from year to year as it was starting to waking up. That's why I call it the white whale that wakes up, because when you look at it, it looks like a sleeping white whale that is slowly emerging, and maybe will surge and maybe will collapse. So that's why we investigate this glacier, and we install different instruments at different locations where you have the yellow or the green stars. So, and here starts the different curve. You can flash it, and you can see in details what we have been doing on this glacier. Just wanted to highlight that what we are doing is accessing to the bed of the glacier, and the glacier is not only a thin layer of water. But here this glacier is more than 300 meters, and that's how you can see that glacier have a huge potential in sea level rise, because it's a huge amount of water that is stored in this glacier up in the Arctic. And what we have been doing is that we have been installing instruments at the base of the glacier, really to understand how well it is coupled or not to the base of the glacier. And that's just some picture of the field. And I just wanted to briefly highlight you what we observe. At the top, so it's 1 year of data of measurement. At the top we have the blue curve that shows the total amount of melt. So surface melt, because temperature gets positive during summer. And what I want you to focus on is the black curve at the bottom, which is called the seismic intensity. And it shows that the more melt we have, the more seismic activity we have, because the glacier starts moving, which what I want to highlight here is that with seismic you can really investigate glacier displacement, and therefore kind of know a bit before when a glacier is moving or when does the glacier start to move, the same way as we do for earthquake. So what has been done for earthquake for 50 be applied now on the glaciers to monitor them and maybe do some early warning systems. And now that I've been showing you some figures and some graphics, I wanted to present you a sound and a little travels to the Arctic and to the bowels of glacier. So it's a 5-minute piece, and I hope the sound will be okay, and I'll let you to this sound. Then I think you can touch the sound now. Yeah. It's a bit more difficult than I thought to hear it.
It's a very impressive record to witness. That is something that was actually took many years and many trials.
We got these two perspectives, these two friends that's close to the glacier.
Elektrometer mottatt. Vind på flyplassen er fra 80 grader, 14 knop, 1005.
I've always been surprised by things that happened on the glacier.
But then there are a lot of people that think science is, climate change is an opinion. Or science is an opinion. Without listening to the work of the one that I do.
What should I do with this geophone?
Put them collected all together in one place.
And should I just collect the geophones that are collected or not?
Can we just have like 30 seconds of silence?
Great. So, yeah. So you can find the sound on SoundCloud, and it was a little travel from southern Europe, from Italy. Maybe you've heard some voices, and going up to the Arctic, towards the interior of the glaciers. So the idea was really to take you towards the glaciers, that you see a lot of numbers, a lot of figures, but to remember that it's also moving objects. And what triggered me to make you hear this today is that 50 years ago we had this album that was called The Song of the Humpback Whales, and you've heard maybe some sounds of the whales during the piece. And this piece of music that was released, what was one of the triggering of the moratory around whaling, because people realized that whales had different sensitivities, and the fact that they could hear it made people change. So maybe with the sound of the glacier, we could do something a bit similar, and just knowing that it's not just numbers or objects, but just opening a new perspective by listening to the Arctic and the glaciers. Thank you.
Any questions right now for Ugo?
Yeah, so the question was like, do we have longer term record? So basically, every measurement we do can be transformed into sound. So we have years of glacier sounds. And what we start to see is that some places become more and more quiet because the glaciers start to disappear. While places start to be more and more active, the glaciers are accelerating and collapsing. So it's a lot of sounds now. I think we could cut down the questions and just listen to it.
Sometimes you gotta say stuff loud and never say something. As we go by, keep on this motion. Cryosphere Pavilion, it's the polar oceans. Up to the north, and protect the polar bears.
General public, what about policymakers that you may have met? So what has been their reaction to these sounds? Were they surprised, for example, by listening to how active these glaciers could be?
Yeah, so I haven't met a lot of policymakers yet, but I'm hoping that these sounds will come to their ears. But most of the people I've met, which is more like civil society and adult kids and teachers, were surprised by the sound, that it makes a sound. And there were like some kids who were saying, oh, it's alive. And I think it was the main impression that I had, is that everyone was like, oh, it's something that is actually moving and making sounds like it's crying. So that was most of the results. But I'm looking forward to policymakers to hear this.